All right, number 3, it says we want to match each graph to the following functions. So I'm going to make this one full screen, and we'll be able to see everything here. Now, there's a couple of things, a couple of different ways you can do this. So in class, we discussed looking at the y-intercept. So, and then there are some subtle differences that we'll discuss. So let's first, if we do the y-intercept, this equation, this graph would cross at 0. We don't have a constant term. Now, there is also one more that has a y-intercept of 0. That would be this one. So we got two equations that cross the y-axis at 0. The difference is one has a minus 4x, one has a plus 4x. All right, so let's do this. We're going to graph it. I want you to see the difference in these. So I'm going to do x squared and then plus 4x. And then we're going to go down and we're going to do, I'm going to arrow to the front. So my cursor, arrow twice so that it's on this line. Now if you have an 84 or a graphing calculator color, you won't have to do this because your lines will be in different colors, but mine is a black and white. So I'm going to go to the front and hit enter once, and that will make my second equation be a bold line so I can see the difference. So x squared minus 4x. Okay, we're going to graph and we'll see the difference. So that's the first one, and that's the second one. All right, so let's talk about the difference. So the first equation that I graphed was the plus 4x. Now, although this is not in vertex form, where you can see the transformation where this graph has been shifted, we can get an indication of what's going on. Remember when we talked about transformations in 3.5, the plus the x term would shift it to the left, and the minus x term shifted to the right. It did the opposite of what we thought. And so here we can see that both those equations are crossing at the origin where y is 0. The first equation with the plus 4 shifted left 4 units. So we can pick out the graph down here, number 18, that shifted to the left 4 units. Well, not actually shifted to the left 4 units, but it shifted to the left. You also have one ordered pair, this -2, -4. If you were to plug in -2 for x in this equation, we would get a -4 for y. We can see that from the graph. If I go second graph and see the table, and I go up to -2, the first equation, y1, shows me a -4. And then the other graph that matched that one was this one. Was this one the same one? On the other side, +2 gives us a -4. And if I put that one up, down here, +2, that's the -4. So that matches with the second equation we plugged in. So you can, the idea that you want to do to solve these is find the y-intercept, and if you have more than one, then we can use that middle term to determine if it shifts left or right. And so we only have two graphs that cross at 0. That's the 18 and 19. One shifted left, one shifted right, and it's the opposite sign. The plus shifts it left. So I'm going to drop that one here, and the minus shifts it right. Okay, and from there we'll do the rest of them the same way. So I have a +4, +4 as a y-intercept, and this one also +4 as a y-intercept. Again, the difference, this one is going to shift left because of the plus. This one is going to shift right. Now I can't say that it's shifting left 4 units. We just know that it's shifting toward the left. So we're going to find the y-intercept of 4. Looks like maybe the 15 and 16 graph. If we count 1, 2, 3, 4, this is where it's actually crossing at 4. It looks like it's close, but it's really hard to tell. And then if we look at number 16, We also have 1, 2, 3, yeah, crossing at 4. So it's out of 15 and 16. These are the two that we're determining between. This one is going to shift left. So the one that's on the left-hand side here, because that point, when I say left, I'm looking at the vertex. That very center point is to the left side of this y-axis. And this one will shift right. So I'm looking at that vertex. It's on the right side of the y-axis. All right, now we have a y-intercept of 6. We have two of them. One shifts right. So I'm looking for a y-intercept of 6. Looks like these two graphs, 17 and 20. And I want the one that's going to shift to the right first. So that would be the graph 17. Number 20 is shifting to the left. And so we would go there, here. And again, if you zoom in, you get the better picture and you can kind of count those tick marks. 1, 2, 3, 4, 5. It's close, but here at 6 is when it's actually going across. All right, and then we have our last two. And these are not so bad because one has a negative out front, which means it's opening down. And there's only one that's opening down. And by default, or process of elimination, our last one will be opening up and crossing at a y-intercept of -5. And we can see 0, -5 here. So this is how I would recommend you match your graphs. Let's check. I got to minimize this so I can check, and they give us the OK.